Master, if life in the universe is most likely not an isolated phenomenon, then why haven't we found any solid evidence of extraterrestrial life so far?
That's a classic question. In science, we usually call it the Fermi paradox. Even if the probability of life emerging is extremely low, the universe is so vast and so old that the existence of other life forms seems almost inevitable. Yet we've never encountered any of them. So where are they? This question involves probability, time, physical limitation, and the fate of civilizations all at once. So if you want to answer what's the most likely explanation, you have to break the problem down instead of looking for a single answer.
Maybe the assumption itself is wrong. What if the odds of life appearing are unimaginably small? In that case, life may exist in the universe, but its density would be incredibly low.
That's exactly the first explanation. Although we can describe the formation of life through chemical evolution, one of the steps in that process may be extraordinarily rare. Perhaps it only happened once on Earth. If that's true, then the overwhelming majority of planets in the universe are simply dead. However, this explanation has gradually become less mainstream in recent years. The reason is that we've discovered a huge number of organic molecules throughout the universe. We've even detected complex chemical compounds in comets and interstellar clouds. That suggests the raw ingredients for life are not actually rare. So a more reasonable question becomes, what happened after life appeared?
What do you mean by what happened after it?
You can think of the journey from the universe to civilization as a chain. Planets form, simple life emerges, complex life evolves, intelligent life appears, a technological civilization develops. The civilization survives for a long time. The civilization expands into interstellar space. The essence of the Fermi paradox is asking, which step is extremely difficult? This is the famous idea known as the Great Filter.
I know this one. The Great Filter means that somewhere along this evolutionary chain, there's one or more incredibly difficult barriers, where the vast majority of life or civilizations got filtered out.
Exactly. If the Great Filter is behind us, for example, during the origin of life or the evolution of complex life, then the reason we're here is because we've already passed the hardest step. That's a relatively optimistic scenario. But if the filter lies ahead of us, such as during the long-term survival of technological civilization or interstellar expansion, then the conclusion becomes much more frightening. Most civilizations disappear after reaching a certain stage of development.
Is there any evidence that the filter is ahead of us?
No direct evidence, but there are some indirect hints. For example, life appeared relatively early on Earth, yet complex life took an incredibly long time to evolve. More importantly, only one species seems to have developed advanced intelligence and a technological civilization. That suggests going from life to complex life may be difficult. Going from complex life to an intelligent civilization may be even harder. On top of that, modern civilization faces some very real risk: nuclear war, ecological collapse, technological failure, such as artificial intelligence. All of these hint at one possibility: civilizations may reach a dead end surprisingly easily.
That makes sense, but it still feels like something's missing.
Another very important explanation is time mismatch. The universe is about 13.8 billion years old, while a civilization may only last anywhere from a few thousand to a few tens of thousands of years. Even if countless civilizations exist, they probably don't emerge during the same period. Imagine a dark field filled with fireflies. Each one only lights up for a brief moment. The odds of seeing two flash at exactly the same time are quite small. So civilizations may simply exist at different times, making it impossible for them to observe one another.
That really makes sense. When you think about it, humanity has only had civilization for a few thousand years. And we've only had technology capable of meaningfully observing beyond Earth for about a century. If an alien civilization really visited Earth in the past, it would have been far more likely to encounter Earth during some other point in its history, say the Jurassic period, or even 200 or 300 million years ago.
Exactly. Even if aliens really had contacted humans in the distant past, and those encounters were recorded, they would most likely have been treated as ancient myths. After all, human history only becomes truly reliable around the 18th century, and ever since then, we've mainly searched for extraterrestrial civilizations through radio signals, which is itself a major limitation. What's more, our own communication technology has been evolving rapidly, moving away from broad radio broadcasts toward methods that are far more efficient and much harder to detect. If a civilization reaches a more advanced state, it may not use signals that are easy to detect across interstellar distances at all.
Or maybe it's simply impossible to detect them.
Absolutely. That's another bold idea that's become quite popular. When we say civilizations often reach a dead end, perhaps that only applies in the physical sense. In other words, many civilizations may have gone extinct over time, but it's also possible that many eventually abandoned their biological bodies and transformed into entirely different forms of existence. You have to remember that interstellar travel is incredibly difficult. The speed of light places a hard limit on travel, even if a civilization wants to expand. Doing so would take an unimaginably long time. Problems involving resources, energy, and technology may simply make large-scale interstellar colonization impractical. Under those circumstances, even if multiple civilizations exist throughout the universe, they would remain trapped within their own star system, isolated from one another. Perhaps abandoning their physical bodies could solve that problem. Once you no longer have mass, you would no longer be constrained by the speed of light. If that turned out to be true, then humanity would face two very different kinds of civilization. The civilizations that cannot abandon their physical bodies remain bound by the laws of physics. They're trapped on the tiny islands where they were born, separated by the immense distances of the universe. The chances of them ever encountering humanity would be almost zero. The other type of civilization would no longer need massive amounts of energy, would no longer expand physically, and might no longer leave any obvious traces behind. From our perspective, they would simply appear to have disappeared. Either way, humanity would never cross paths with them. Although this idea can't really be falsified, it is certainly one possible explanation.
Still, this explanation feels fairly optimistic. If the reason we haven't met aliens is simply because our time windows don't overlap, then as long as humanity survives long enough, we'll eventually encounter another civilization.
The Fermi paradox was never meant to say that extraterrestrials don't exist. Instead, it reminds us that between life emerges and the civilization becomes observable, there's a whole series of extremely demanding conditions. When all of those conditions are stacked together, civilizations that are actually reachable become extraordinarily rare. Within that framework, the Fermi paradox is no longer a contradiction. It's simply the natural outcome. It doesn't deny the existence of extraterrestrial civilization. It merely tells us that the universe may not be silent. We just aren't able to hear it yet.
It's kind of like this. Imagine you could live forever. If you bought one lottery ticket every single day, then eventually you'd win. It might happen tomorrow, or it might happen 10,000 years from now. But as long as you live long enough, it's inevitable.
That's an interesting analogy. Humanity encountering an alien civilization right now would be like buying your very first lottery ticket and winning the jackpot the very next day. It's not impossible. The probability is simply extremely low. Under that assumption, if you truly wanted to win the lottery someday, your real goal would be figuring out how to achieve immortality. Likewise, for humanity, what we should really be thinking about is our own long-term survival. If civilizations are generally short-lived, then how can we extend the lifespan of our own civilization? If the next step for civilization is to abandon the physical body, then are we capable of accomplishing such a transformation? Objectively speaking, nothing in the universe lasts forever. Even so, I still hope human civilization survives long enough to leave a bold mark on the history of the universe. Though by then, I certainly won't be around to see it.